Alright, in this video I want to talk about just the basic sine and cosine waves. What I mean by that is I want to look at these two graphs here, sine x and cosine x. Later we'll build up into things that are more complicated, but for now I just want to look at sine x and cosine x. We already put that, we drew those in the last video. But I want to look at some terminology for it, and I want to show you some drawings that you need to be able to recreate from memory. All right, the sine wave, I'm going to draw these down here, and then we'll come back and talk about the bullet points I've got. Y equals sine x looks like this. I'm just going to draw one period. This is 2 pi over here, and the wave, see, this is 1 and this is -1. Sine starts here, it crosses the axis there, and it's going to end there. Halfway in between these first two is where it'll have its maximum. Halfway between the second two is where it has its minimum. So if I draw this, that's y equals sine x, one period of it. I'm going to label this point in the middle. This is pi. And let's see, this should be right here at the very top. So sine looks like that. Cosine, as we saw before, has the same sort of shape, but cosine starts at the top and it ends at the top. In the middle here at pi, cosine is -1. And then at these quarter points, I call them, that's going to be at, this is pi over 2 and this is 3 pi over 2, cosine is 0. So if you connect this up, you get this for one period. So what we have here is 1 period of sine x and cosine x. So let's go up here and look at this stuff. The amplitude of a sine or cosine wave is the distance from the midline to the top or bottom. So that's going to be the distance from here up to there or down to there. So both of these, the amplitude is 1. Over here, this is the midline, and the amplitude is 1, that distance. The period is the distance from a point on one cycle of the wave to the corresponding point on the next cycle. So on here, both of these things have a period of 2 pi. I think I've got that written up here. Yeah, the amplitude is 1 and the period is 2 pi. That's the distance from the beginning to the end of a period. If I came over here and drew some additional periods, that's also the distance from, say, the max here over to the corresponding point on the next period. And let's see, what else do I have here? The graph starts at 0, at y equals 0, and the graph of cosine starts at y equal 1. And the endpoints of the first cycle, I've got first in quotes there because, well, I mean, it has infinitely many going back in both directions. But the endpoints of the first cycle are 0 and 2 pi, and there are 5 key points there. That's what I started out by drawing. When you want to draw one period of a sine or a cosine, you want to draw the 5 points here and then connect them up. So that's these are the two graphs you should memorize. And the next thing we're going to look at is if we want to start varying the amplitude and the period or frequency. And on all of those problems, what we're going to do is figure out the we're going to figure out where to draw these 5 points and then connect them up. But let's look at this. It says let's examine the graphs of y equals a sine bx minus c and a cosine bx minus c. So let's do that with Desmos. And I'm going to turn off the cosine for now, and we'll just look at the sine. I'm going to change this to a sine bx minus c And let's see, why is it giving me an error? Let me just delete all this and start over. All right, so it's giving me this, and I've got sliders for all these things that I can control. Now, one thing I want to do on here, let me get this window smaller so you can see the portion I want to show you. If you come over here and click the little wrench, it gives you these options. And on my x-axis, I'm going to change my step here to pi. If you just type in pi, it'll put pi on there. And that's nice because now we've got the x-axis is labeled in multiples of pi over 2 instead of just multiples of 1. And let's adjust this. I'm going to leave a at 1. I'm going to leave b at 1. C I'm going to put back to 0. So if we do this, notice what we've got here is, sorry, this is a little fiddly to scroll with, but what we've got right here is just the regular sine graph going from 0 to 2 pi. Then we've got a second period over there. If I adjust A, when A gets bigger, it makes the amplitude change. And that makes good sense. It's multiplied by the entire sine, so that's going to change the vertical stretch of the thing. So if I make A less than 1, it squishes it down. If I make A bigger than 1, it makes it grow. And then if you go negative, it flips it upside down. So we can vary the amplitude like that. B and C are a little more interesting. If I start playing around with B, if B gets big, then that makes my the period smaller. If B gets between 0 and 1, it stretches it out. Notice if B equals 0, then it just makes it A equals sine of C, which is a constant, so you get a line. Now, we don't usually make B negative. I guess we could, and it would reflect the graph. Notice now, instead of having the graph start out going up, it's going down. So it actually reflected it vertically, or horizontally. All right. Usually we're going to make B be something positive, but B determines the period. Now C, we're not going to talk about it a lot until we get to the next topic, but C does what's called a phase shift. If I move C back and forth, it adjusts the left to right phase of the thing. So kind of an interesting thing, if I move C over here to negative, well, if I could make it negative pi over 2, whoops. If I could adjust C to be negative pi over 2, then what we've got here is it's still a sine wave, but it's actually the same graph that we would have for a cosine. So anyway, these things adjust the phase, the amplitude, and the period. Now, one other thing we can do is if you put something else on the end, that will change the midline and let you, raise the thing up and down. But the main stuff I want to concentrate on for now is the phase and the amplitude. I'm sorry, the period and the amplitude. All right, let's look at this. Facts. The amplitude is the absolute value of A. If A is negative, the graph is flipped vertically. The period, it turns out, is 2 pi over B. And the reason for that is the original period of just sine is 2 pi. And if you divide that by B, that will change the period. So anyway, memorize this. And the phase shift is C over B, and we'll use that later. So let's do a quick example here. If we were to graph y equals minus 2 sine x, all right, if the only thing this is doing is it's taking the sine wave and it's stretching it by 2, or in other words, the amplitude is 2, and it's also flipped vertically. So if I were to graph this, it would look like this. Let's say this is 1, this is -1. So if this is pi and this is 2 pi out here, it's still going to start, end, and in the middle be here. But at this quarter point, it's stretched down to -2. And at this quarter point here, it's stretched up to +2. All right, we'll do more examples of this in the next video.